Sounds kind of complicated, but this is a really important public health and social issue, as well as a geological issue. So I first came up with the idea for the project when I was in field camp in Java. This was last summer, and on this study abroad, we focused on the importance of scientific research, public health outreach, and disaster mitigation, placing equal emphasis on all three components. And this has really shaped my research in this topic of artisanal gold mining. So before I go here, the problem is that 100 to 200,000 Indonesians suffered from mercury poisoning related to artisanal gold mining every year. It's a small-scale activity. But no studies have been done about how this mercury is being transported throughout the system. I can't find a single paper in Indonesia that really explains this. And so my background in the subject is that I do mentored research at BYU, and I've been working in the Provo River project. And we're analyzing how mercury is migrating on the upper part of the Provo River above Jordanelle Dam. I do a lot of water chemistry analysis, total mercury, methane mercury, anions, cations. This is all organic carbon. So that's kind of my background and credentials for working on a question like this. So in our Provo River project, as you can see from the graphs on the left side, we have a spike in mercury concentrations during our peak flow, which is occurring in May to June, our peak runoff. And this graph right here shows 24 hours sampling. We sample the river over a period of 24 hours. Hours 10, between 5 and 10, occur during the hours of midnight, where peak flow, as you can see in the light blue line. As flow peaks, we have peaks of mercury concentrations in the Provo River. Why is this significant? The Provo River has very low ambient levels of mercury. We're talking 5, 6 nanograms per liter. This is really, really low. However, the mercury bioaccumulates in Jordanelle Dam. And we actually have a fish consumption advisory for mercury in Jordanelle Dam. So this tiny input of mercury has a large effect. And this is due to the mercury cycle. So mercury is a naturally occurring element. It occurs in especially volcanic compounds. It comes from the earth. And as these mercury-bearing rocks weather, mercury is released into the environment. Mercury can volatilize into the air as a gas. It can also be converted into the most toxic forms. As you see in the bottom of the slide, elemental mercury can be ionized and converted by bacteria into methylmercury. The problems with these components, methylmercury and dimethylmercury, are that they are lipid soluble. They bind to fat. And so as a fish comes in contact with methylmercury, eats some sediment at the bottom, its levels of mercury rise. And as mercury bioaccumulates through the food chain, it presents a significant risk to human health, which we're going to discuss. This slide was from the United Nations Environmental Program. They're really trying to encourage mercury awareness throughout the world. Some of the health effects include birth defects, neurological disorders, loss of coordination, very terrible. And the problem with artisanal gold mining is that mercury is central to the process. So artisanal gold miners go out in their backyard, basically, pan for gold, and use mercury as an amalgam to bind with the gold. Then they burn off this mercury and release it to the environment to purify or refine the gold. And it's estimated that 95% of the mercury used in this process is lost to the environment, which is extremely hazardous. Even worse, even though it's a small scale regionally, it's large scale worldwide. It is the largest component of anthropogenic mercury emissions, accounting for 37%. So this is extremely significant. It employs 1 million people in Indonesia, and it's illegal. So there comes our problem. How do we identify where ASGM is taking place? Because it's an illegal activity. So we do know the health effects, though. So even if we don't know exact mining locations, we do know that there are birth defects, about 10 to 20,000 children suffering birth defects related to mercury exposure. And these are just estimates because it's an illegal activity. We really don't know. The numbers could be much higher. And this data was from an Indonesian scientist called Dr. Ismawati. She's one of the foremost researchers of ASGM in Indonesia. And she does public health, so she identifies areas where there are elevated levels of mercury. And her focus is education. So she identifies these areas and then teaches people the hazards of mercury. Don't burn it in your kitchen. It's not good for your health. And there's been a few studies done on it. Like I said, there's been lots of studies on the health effects. We've identified areas where there's elevated levels of mercury in human hair, in crops, but there hasn't been a lot of research on how mercury is transported within the system in sediment. Is it transported in the tailings? Is it dissolved? How is it being methylated within the system? We just don't know these questions, and this is what I propose that we look into. So why is there mercury in here, and gold deposits in Indonesia in the first place? Well, Indonesia is a large volcanic arc. Arc formation was influenced by the subduction of the Australian plate under the Sunda plate, and this has resulted in subduction tectonics and porphyry gold deposits throughout the island. And as the price of gold has risen, the demand, the level of artisanal gold mining has increased. It's more profitable. So, as I was saying, I talked to Ismawati. She is the foremost researcher again. She's the 2009 recipient of the Goldman Environmental Award for her research. And I wanted to know, where is this taking place in Indonesia? And she identified a really good spot called the Wonogiri Regency in central Java. This is unpublished research, but in an email to me, she said that last year, her researchers found high levels of mercury in bananas, rice, cassavas, and guava in the area. So we know it's a problem, we know where it's occurring, but we don't know how it's being transported. So let's do a zoom in on the area. Okay, so I created this map from Google Earth. What makes this site so interesting is that you have anthropogenic mercury from artisanal gold mining sites, as well as volcanic mercury related to the Lawu volcano. This site also sits adjacent to the Gajah Mungkur Reservoir. This is a huge reservoir that dams the longest river in Java. Millions of people depend on this, the river and the reservoir for water, for irrigation and crops, and as well as downstream. And so I propose investigating how much of the mercury in the system is due to artisanal gold mining, how much is due to volcanic inputs, and how is it bioaccumulating in the reservoir. There has been no research published on this subject, and it's a huge public health hazard for all of the people living in the area. So how do we know that there is mercury in volcanic soils? Well, I found one study, just one, on the composition of volcanic soils in Indonesia. And they said, basically they recommended that the chromium and nickel levels should be taken into account when selecting crops to be grown. They did research mercury. They just took 7 volcanic soil samples from across the island, but not from this particular region. And so I propose that investigating the host rocks in the soil, weathering from them, can help us understand if there are significant volcanic mercury inputs. Now, a better study that I found was conducted in California, and that is the graph you see there on the left. This study in California was in a historic mining area, and they wanted to analyze mercury, methylation, and transportation in their Californian watersheds. And as we know, California has somewhat volcanic tectonic rocks, and so although I can't compare the study to Indonesia directly, we can see a correlation in mercury and methylmercury levels with dissolved organic carbon. So as there's mercury methylation is increased in areas that are anoxic, so low dissolved organic carbon, and they're also correlated with areas of increased soil moisture. And this will become important as we examine the reservoir in question. So this is the Gajah Mungkur Dam. This is that dam on the Solo River, which is adjacent to all these mercury inputs. If you remember earlier, the Jordanelle Reservoir here in Utah, it has a mercury fish consumption advisory, and we have tiny inputs of mercury. This area, I'm anticipating that we will find much higher methylmercury and mercury levels because of the large inputs. The problem here is that the dam has high rates of sedimentation, and so the dam storage capacity has decreased from 630 million cubic meters, that's a tongue twister, to 428 million cubic meters. And these, like we said, like we saw in the Provo River study, high amounts of flow were correlated with higher amounts of mercury concentrations, and so these annual flooding events during the wet season may be correlated with increased mercury. We just don't know. There's no studies. That's why I want to study it. So here's my research proposal. We expect that water chemistry in areas affected by artisanal gold mining will have higher levels of mercury and other toxic trace metals in a control site. Furthermore, we predict there will be a significant difference between background levels of mercury due between volcanic contributions versus anthropogenic emissions, and during the rainy season versus the dry season. Again, I haven't been able to actually go to Indonesia, but I've conducted a lot of preliminary research, reaching out to Dr. Ismawati. She's identified government officials to work with and the people to communicate with. So I'm going to obtain research visas. I'd love to go to Indonesia this summer and collect some samples to analyze a snapshot of what's going on with the water chemistry, because we just don't know. Then we'll take these samples back to BYU and analyze them. And then, depending on our data, I'd love to go back during the wet season and dry season to compare the results. And then this brings me to the overarching theme I really want to communicate to you, is the importance of communicating geologic science. A lot of times I feel like there's a disconnect between what is published in scientific journals and versus what people understand and are implementing in their daily lives. A great example would be climate change. We don't need to go into that. But as I conduct this project, I really want to be able to reach out to people in their own language. I've been studying Indonesian. When we go there, I want to work with Indonesian geologists and local ministries so that people understand the hazards of mercury in the areas they live, understand how it's being transported, and so that they can make the changes within their communities to mitigate the risk of mercury. This is something I feel really strongly about. Taking from the advice of Dr. Ismawati, she publishes her information in Indonesian and English so that the government agencies in these areas can have access to it. One great story, this area, the Eyring Regency, was actually studied by another team of researchers before Dr. Ismawati. And the locals had no idea. So a group came in, studied the mercury levels, and didn't tell anybody. That's like investigating nuclear radiation and not telling the people there that there's radiation, something extremely harmful. And this taught me that it's so important to work with the locals so that they understand what we're doing, trust the science that we're doing, and make changes. So I'm so thankful for you guys for listening. Do you guys have any questions for me?
So how close are you?